Okay, today we're going to look at graphs of exponential and log functions, and we're going to compare them and look at their characteristics. And we're going to graph them by transformations, like we've done a lot of things. But first, when I'm talking about this parent function of y 2 to the x, I'm going to start with putting in -3. When I put in -3, remember it's 1 over 2 cubed, or 1/8. When I put in 2, it's 1/4. When I put in -1, 1/2. Anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. So the parent function looks like this. And we're going to go half. And we're going to get closer and closer to the x-axis, but it will never, ever, ever cross the x-axis. So it's going to look like this. Okay, so looking at that graph, now if this would be to the third power, we would go up to 3 here, and then 2 would go up to 9. So it's going to go up depending on your base. If your base is a fraction, it's going to be decay. So here's this graph again. Our x-intercept, there is none. Our y-intercept is 0, 1. Horizontal asymptote is going to be the x-axis, or y equals 0. There is no vertical. The domain is going to be all real numbers, so -infinity to infinity. The range is going to be restricted by our asymptote, so it's going to be greater than 0. Our end behavior, as x goes to infinity, y is going off to infinity. As x goes to -infinity, so it goes this way, y goes to 0. So y gets closer and closer to 0. So that's new compared to the things that we've done. And this is increasing the whole way. So it's increasing from -infinity to infinity. So as we read the graph, it's going to get bigger, 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 and bigger. So our transformations that we've been studying all year still hold for this. So if this is A is positive, it's a vertical stretch, and it's going to multiply our y values by A. Okay, our h, we'll move it right or left. If this is minus h, it goes right. If it's positive plus h, it goes left. Positive k, move your unit k up k units. Minus k, move it down. And then you've got your flips. Okay, same rules that we've had with transformations all along. So this is how I like to do these parent functions. I like to take and draw in my new asymptotes. So this is what it's going to do, is it's going to draw, oh, let's go back. It's going to draw new asymptotes at x is 3 and 4. Now, one of the key points is whenever, and I didn't mention this earlier, but whenever my exponent is 0, my y value is always going to be 1. So it crosses the y-axis here at 1, 0. So when I've drawn in my new axes, it's going to go here at 0, 1. It's not really 0, 1. It's the point 3, 5, but I look at that as I've moved the axes, so now I'm going to move the points. So normally I would have gone here, so over 1 and up 2 from where the intersect there, And then if I go over to the 2, I'm going to go up 4. And it's just going to be here. And all I've done is I've moved my axes and my graph stays the same. Now, my domain is going to stay the same. It's going to be all real numbers. But my range is going to change. And it's going to be from here. And it's not included because it will never touch to positive infinity. Okay. And my horizontal asymptote is now going to be y equals 4. Okay. There is not going to be any roots or x-intercepts. To find my y-intercept, remember I can put 0 in for y, and I can solve that. I'm sorry, we're going to put 0 in for x and solve that. So if I put 0 in for x, I'm going to get y equals 2 times -3 plus 4. So that's going to be 1/8 plus 4. So my y-intercept is going to be 0 and 4 and 1/8. And I'm okay with that being 4 and 1/8. Right? Next example. Now this time the 1/2 is going to give us decay. Okay. So we're not going to go right or left, but we're going to go down 2. Okay. If I put 0 in for x, I've got this point right here. Okay. And now instead of, and because of this negative sign here, it's going to be flipped over here. So it's actually going to be right there. Normally with the decay, I would go in the opposite direction. So over 1 and up 1, and then over 2 and up 4 here, but, and then a half here. Because of this 2, I'm going to change my y value and make it twice as big. So instead of going from this point over 1 and up 1, I'm going to go over 1 and then up to the 3. So I'm going to make it twice as high, 2 points away from there. 1, 2, 3, went too far. 4. Okay, and then this point, instead of being off this new asymptote 1, 2, 3, 4, 5 places, it's going to go 10 places. So it's going to go down here. And it's going to look like that. So it's just going to go up quicker. Okay. So whenever this is a fraction or decimal, whenever it's smaller than 1, I should say, it's going to give it that kind of appearance. And then we flipped it because of the negative here. And this made it twice as high. All right. Now, logs, we said, were the inverse of exponential. So with the inverse, the easiest thing to do is switch my x and y points. So I've got 0, 1. That means with the log, I've got 1, 0. Okay. And then I've got the point 1, 2. That means I have the point 2, 1. Okay. And then I'm going to have a half and -1. Okay. So my log is going to look like this. So there's my inverse. So that's my log. And what this one right here is y equals log base of 2x. All right. So now my x-intercept, instead of my y-intercept being 0, 1, my x-intercept is going to be 1, 0. Okay. There is no y-intercept. There is no horizontal asymptote. My vertical asymptote is going to be x equals 0 because it's the y-axis. In this, my domain, when it was an exponential, was all reals. Well, now my range is going to be all reals. My domain is going to be the one that's restricted from 0 to infinity. And then my end behavior as x approaches infinity, y approaches infinity. And then as x approaches negative infinity, this is also going to go to negative infinity. And this time again, it's all increasing. So increasing from negative infinity to infinity. Okay, so my key points in here are going to be 1, 0 and 2, 1. Okay, and again, I'm going to graph using my parent. All of my, everything holds again. This moves right or left. This moves up or down. This is your scale factor. Okay, so if I'm going to graph this, this makes my axes move right too. So that's going to be my vertical asymptote is going to be x equals 2. And then we're going to move up 3. Right? And I said that the 0.10 is critical. So we're going to go to 1, 0 on our, and I say, when I can't see me, but when I say new axes, I mean the ones that we've drawn in here. And then up 1 over 1, up 2, and then over to 4 from there. And there is my log. Okay, in this case, my domain is going to go from 2 to infinity. My range is going to be what's restricted, or what's all real numbers. And then my vertical asymptote, we said, was x equals 2. Right now we're going to go left 2 because of this 2 right here, up 1. And we're going to have a point right here at the 1, 0 of our new axes. This time we're going to go 3 times as high. So instead of going up 1, we're going to go up 3 and over 1, up 6, and then 3 to there. And there's my log. All right, so hopefully you have looked at how we can graph logs and exponentials very quickly with our transformations. Have a math-tastic day.